Good morning. Good morning. So what's it like sitting in a waiting room?
It just says waiting for host to let you in.
Do you
Blank
guys
screen.
talk to anybody? Can you talk to each other?
No,
Okay, do you see each other?
no, it's just a message that pops up.
Okay. Any questions? You want to wait till questions tomorrow? All right. Well, I've put stuff in the grade book. You probably have seen that already. I've corrected free response. You should see that already. We need to be a little bit tighter on our limits to get credit. I'm missing a couple of people yet. The other thing is I put out a sample problem that I want you. It's 2 pages, 4 parts. I think I tell you it's a calculator problem in give yourself 15 minutes to do, and then just take a picture and send it in. But you want to just be able to use your calculator, and that's it. So you want me to evaluate it correctly so you have an idea what you need to do. So you have a week to get that done. That's um, yes, sir.
For the multiple choice ones on the AP board part,
Yeah.
on Schoology it says to do A and B, but on the AP it says to do A, B, and C.
Yeah, I think I gave 3 points. I think that's a typo on my part. I think it should be A through C, and it's worth 3 points, one for each of those. And then the free response are each worth 2 points.
Okay.
All righty. All right. So I got a problem I'm going to give you. And you're going to need a, yes, Landry.
Can you review the 51 through 59 on section 8.2?
Okay. I don't have those problems right in front of me. Can you give me a sample of those? I wonder if I can work on this. Can you guys see this?
Yeah.
All right, so what's the problem? 51 through 59?
The instructions are describe the type of indeterminate form, if any, that is obtained by direct substitution.
Yep. So
Evaluate the limit using L'Hopital's rule if
Yep.
necessary. Use the graphing utility to graph the function, verify the result in part B.
Okay.
And here's one of the ones. It says the limit as x approaches 1 from the right
Okay, of what?
The ln of x raised to x minus 1.
Well, if I put in substitution, I get 0 to the 0, correct? So are all 51 through 59 like this? Because this is a BC topic right here, and I did not want to give this to you. So did I give you odd or did I give you even?
They're all like that.
They're all like this?
Most of them are harder than that, like bigger
Yeah.
than that.
Yeah. So the other, the examples I gave you in your notes are pretty straightforward. We do this in BC, and you don't have to do it in here. So I think I accidentally gave you some BC problems. So you can skip 51 through 59. Okay.
Okay.
Thank you.
Yeah. Sorry about that. All right. Let's get to a problem you will have to do. And you're going to need a calculator on this. And I think it's this one. Yeah, it's this one. So can you guys see this okay? And so back when you could go to Shields, which is one of the places I go to fairly often, sometimes you see people wait in line go up that escalator. So what they tell you is people staying in line for an escalator are getting on the escalator at this rate, where RFT is measured in people per second, and T is measured in seconds. So they get on the escalator, they write it up, and then, so once they step on the escalator, they're entering the line at this rate, and they're leaving the line at a constant rate of 0.7 people per second. And currently there are 20 people in line. So whether they're waiting in line to get on an escalator or going on an elevator, or the people are getting in line at this rate, they're leaving the line at this rate, and currently there are 20 people in line. So the first question is, how many people enter the line to get on the escalator during this time interval? And I'm going to give you a couple of minutes to figure that out. And again, you're going to have to do this. This is a calculator problem. It's from 2018. It was the very first free response. This, by the way, this problem's worth 2 points. Owen, do you have an idea?
Do you take the integral of it from 0 to 300?
0 to 300. Of what?
Of the 44
Can I just call it R of t?
R of t, yeah.
Okay. dt?
Yeah.
Okay, so as soon as you write that, you get 1 point. So did you figure it out on your calculator, Owen?
Yeah, I got 270
That is correct. 270 what?
people.
People. Okay, do you see how this is similar to yesterday's problem? I mean, yesterday's was what, 2015? This is 2017. In 2015, they had rain going in at a particular rate into a pipe, rainwater, and then it was leaking out of that pipe at a certain rate, correct? All right, so, and the first question was how much water entered the pipe. Here they're saying, all right, how many people are entering the line? Same type of idea, isn't it? All right, B, during the time period from 0 to 300, what is it, seconds? Yeah, 300 seconds, there are always people in line for the escalator. How many people are in line at time t equals 300? Josh, you think you got an idea of how to set it up?
No, never mind.
Okay.
Do you do 20 plus 270 minus 0.7 times 300?
Yeah, exactly. Okay, so let me write that down, which is ends up being a lot simpler, but I'll show you what they give as a rubric. So I agree with you. I think there are 3 pieces to take a look. Currently, at time 0, there's 20, correct? Those are the people already there. Plus, you just did this integral. These are the people that entered the line. And you know there are people leaving the line. And the people leaving the line are up here, 0.7 for every second that goes by. So it's going to be, what'd you say, 0.7 times?
Times 300.
Yeah, 0.7 times 300. Which is what?
80.
80. Now, there is nothing wrong with that answer. This is how they give the answer in the rubric. You have your 20 plus your integrating from 0 to 300 of R of t, which is what you just did in the first problem, correct? Minus 0.7, oops, sorry about this, 0.7 dt. Because when you take the antiderivative, you can break these up into two parts. So this is the 270, and this would be a minus 0.7 t, the antiderivative. Then you'd plug in 300, and then you'd plug in 0, which is 0. But there is nothing wrong with the form that you gave. So again, number of people you had to start with, the number of people that you gained, the number of people you took away. So this one was worth 2 points. A was worth 2 points. B was worth 2 points. C, for time greater than 300, what is the first time that there are no people in line for the escalator? And by the way, as my hint, up here, if you look at this part right here, this is telling you that after 300 seconds, no one gets in line. Alex Freihammer, can you hear me?
Yeah.
Oh, you think you have an idea how to do this?
So I think you should take the 80 from the part that we just did.
Yeah, because you got to get rid of 80 people, correct?
Yeah.
Okay, let me get, I'm having issues with seeing today. Okay, so let me write it in this space. So I got 80 people, right?
Yeah. Yep. And then maybe subtract 0.7x for how many people leave per second.
So write 80 minus 0.7 t,
Yeah. And then set that equal to 0.
set that equal to 0. Okay, so 80 would equal 0.7 t.
Yeah.
Correct?
Yep.
I go from here to here. Okay, so if I take 80, do you have your calculator with you?
Yeah. I got 114.286.
Is that the answer?
No, you need to add 300 to that.
Did you say 286?
Yes.
And so you're, because this is how many seconds afterwards, correct?
Right. So add 300 to that.
Add 300. So you got 414.286
Yes.
seconds, correct?
Yep.
All right, so that is correct. And that problem was worth 1 point. So now we're at 5 points. So you know, comparing this one to the one I talked about yesterday, this problem and this problem were very similar to the problem yesterday. This is kind of a unique one, right? It's a different kind of point of view. This one is kind of like I did yesterday. And so it says for the closed interval, and that's a hint, from the closed interval 0 to 300, at what time t is the number of people in line at a minimum? To the nearest whole number, and so that make sure you see its nearest whole number and you're not rounding to 3 decimals in this case. Find the number of people in line at this time and then justify your answer. Adam Burton, are you out there?
Yes, sir.
Oh, it's nice hearing your voice. And thank you for sending me the pictures for those free response.
I did figure out the thing from the question from yesterday. I was just looking at the wrong segment.
Oh, okay. That's cool. That's cool. So on this problem, Adam, where could the minimums be?
Either at the two endpoints, the 0 or the 300,
Okay,
or
let's,
wherever it's starting.
I think that's great. So let's say, let me write this so it's halfway decent here. So it could be at t equals 0, right?
Right?
T equals 0, how many people do I have?
20.
20. And at t equals 300, how many people do I have?
290? Is that it? Nope, never mind. It is 80.
It's 80. Yeah, because we figured that out in B, right?
Right.
And this is another thing they like to do, Adam. They like to take this previous information they give you, and all of a sudden it kind of accumulates on itself, okay? So we know it's not at 300, correct?
Right.
Okay. Where else do I need to look?
Where it changes concavity at some point on your graph, but I don't know where that is.
Okay. I agree that we need to look at something. I don't think it's concavity, but let's, I think I graphed it here. So I'm going to show you my calculator. Okay, Adam?
Okay.
Can you see it?
Yep.
All right. So let me go your what? My y equals. So this right here is R of t. Okay.
Okay.
And this is the amount that's being taken away. So I'm going to go to, and I think I showed you this yesterday. Go to vars. Minus vars. And turn that off, turn that off, and now graph. Oh, it's a terrible graph, Adam. Oh, there's something wrong, don't you think? That doesn't look right.
Isn't that supposed to be 44 for Y1?
It might be. Yeah, I would say 44 makes a big difference.
And should you have a 0.7 or a 0.7x for y2?
Well, both of those are rates, correct?
Yeah.
Right? This is a rate and this is a rate. For every x, aren't I subtracting 0.7?
Yeah. So shouldn't there be an x after that?
Well, then you took the antiderivative.
Oh,
It's no
okay.
longer a rate. It computes the number of people you have, correct?
Right.
And I want to graph the rates, right? The rate going in minus the rate going out.
Yeah. Okay.
Well, that's going to be crazy. There we go. All right, Adam, I got you online, correct?
Right?
Okay, so this is y of 3.
Okay.
So this means, because I got, right, this graph is the people, the rate at which people are coming in minus the rate that people are leaving the line, correct?
Correct.
So this means there are more people leaving than entering the line in this period, correct?
Yes.
This means what?
There's more people arriving in line that are leaving the line,
Correct. What is this?
where it's exactly equal.
Correct. What's this?
The same point where it's exactly equal.
Okay. These are called critical numbers. So this means my amount of people is decreasing. It turns around, my amount of people is increasing. It turns around and my amount of people are decreasing. So I started at 20, correct?
Correct.
Then it decreased to this time.
Correct.
Then it increased to this time. And then it decreased to this time, which is 300.
Right.
So here is where I have 20. Here is where I have 80 for amount of people. In other words, if I would go second calc and come down here and take the integral and type in 0, enter 300, I should get 60 because I'm going to have to add 20 to it. Are you with me on that?
Yeah.
And sure enough, I get 60. So I started at 20, I got 60 more, and over here I ended up at 180. So this is that means this increase is bigger than these decreases, basically. So what I need to do, besides looking at those endpoints, I need to look at these critical numbers. I need to know when these equations, this equation right here, this difference equals 0. And so what I'm going to do is when I graph that, I'm going to go second calc here. And I'm going to look at these zeros. And where's my little blinky light? Way over here. And on a Casio, this is a little bit easier to do. So I need to look at how many people I have in line at 33.013. And my guess is that's going to be less than 20 because this graph is negative. I'm decreasing at time, and this is the amount of decrease that I have.
Right.
And I also, AP wants me to consider this, even though I know by this graph that this value here is going to be more than this value here and this value over here. It's going to be more than 80, I think. I think this is maybe the highest amount of people I have waiting in line at this moment, but they still want me to consider it. Is that making sense?
Yeah.
Okay, so again, I'm going to go second calc. Come down here, hit a 0. Move that little blinky light over there. And so this is 166.574772 seconds. So I'm going to integrate. Start at 0. And I'm going to type in what's my time here? 33.013298. And I lost about 16.19656 people. So I started at 20, I'm down around 3-4 people. Do you see that, Adam?
Yeah.
Okay, I'm thinking that's my minimum amount.
That would make sense.
Okay. And now I'm going to go second calc again, because they want me to consider it. I'm going to start at, well, I could do this a couple of things. I could integrate, well, no, I'll go from 0. It's easier for me to type in 0. And then I'm going to integrate to 166.574719. Oops. And then I have, this one will be 158.07. All right. So
Right.
this is what I'm going to write down for my answer. I'm going to write down T equals 33.13, it looks like 33.013. Was that my time? Yeah. And my
Yes.
amount of people was 3.803. And then my other time was, I'm looking at too many things. 166 point 575. 166.575. 5. And my number of people was in at 158.07. All right. So what I'm going to say is this: 33.013 and 166.575 are critical numbers of R of t minus 0.7 and minimums on a closed interval occur at endpoints and critical numbers. At t equals 33.013 seconds, there are 4 people in line.
Mr. Kruger,
Yep.
would you say 4 even though it's people?
Yeah, they asked me to round up so I can get by with it.
Oh yeah, okay.
That's why. In fact, that was a discussion at the AP conference. If any points would be taken off, if they said 3.8, the guy says they should be able to read nearest whole number. And so that's why I brought it up. Okay. But do you see the similarities between this one and the one from yesterday?
Mm-hmm.
Okay. And so the one that, take a look at the one that I sent out and you should see the same type of similarities. All right. So we are done for the day. Tomorrow I'll open up a meeting and you can come and go as you wish. If you have any questions, you can just come in and say, hey, Kruger, I got a question on what I should need to do on here. I think, are you guys able to share your screen with me? Do you know? I see Addie, are you nodding an affirmative?
Yeah.
Okay. So what you could do is maybe show me what you're working on if you're on AP Classroom and I can give you some help or something like that. Okay.
Cool.
Alrighty. You guys have a pleasant day. Tomorrow would be a 2-hour late start anyway because of weather. So pretend you wake up and go, oh my God, the weather's terrible. I guess I'll stay in. You'll just feel good about it. All right. Take care, everyone.
Have a good day.
Yep.